All right, we are going to do Topographic Maps 8.9C. The student is expected to interpret topo maps and satellite views to identify land and erosional features and predict how these features may be shaped by weathering. So there, you guys are going to have access to this video. I just want to kind of go through this data and this information for you so you know what you're looking at when you see all these circles and lines and whatnot on a topographic map. So let's just dive right in. So right over here on the bottom, you see these circles. You see a small circle here, and then, bigger circle, bigger circle, bigger circle. They all mean something. So these lines would be considered contour lines, and they represent a specific measurement above sea level, usually feet or meters above sea level, and they count by a specific number. So, that's kind of how it works. It just kind of shows elevation above sea level. So when you're looking at this picture here, you see these small circles and then bigger ones. You know that you're looking at a hill or a mountain. And so you can see the landform above it is a side view representation of this topographic 2D view as you're looking down on it. And so you have wider contour lines and contour lines that are closer together. So the wider ones would be a much more gradual slope. And then the closer ones together is much more steep. So look over at this picture. Wouldn't this be a really nice walk to go up this gradual slope versus this steep slope? You can see steep here, gradual here. Moving on. So topographic maps use contour lines to show the shape of the landforms at different levels. So we have this one here with lots of circles, then this one here with less. Usually, the one with less is smaller than the one with more. And you're starting to also see numbers next to contour lines. So right here, we are looking at 1440 above sea level. It doesn't say meters or feet, so we aren't going to guess what it is. Probably meters, but who knows? But yeah, that's what it kind of looks like. So definitely start paying attention to what the side view and what the top-down view looks like. You should be able to match hill sizes and whatnot based on 2D topographic view and side view, 3D side view. All right, so we're going to spend a minute here definitely looking at this screen. It says they connect the points of equal elevations. So we have F and G and H. But look at these dark contour lines. We call these index contour lines. The index contour lines will always have a number by them. So it's kind of it's the index. When you think of an index gives you information. So the same thing when you're reading a contour or a topo map. This contour line, this dark one, is the index one, and it will always give you an elevation of some type. So you know where you're starting at. And then if you find the next index contour line, at that point, now you can figure out how much it's counting by. So this one down here is 700, 750, 800. So we know that it's counting by tens. 700, this one will be 710, 720, 30, 40, there's 750, 60, 70, 80, 90, and 800. Contour, so the contour interval will be tens. Yes, and as you can see here, sometimes the highest elevation will have this little triangle with a circle in the middle of it. And so my question that I'll ask you is, why does it not have another contour line? Yeah, because it doesn't go up the full amount to require another contour line. Well, the next question will be, what do you think these contour lines count by? This index is 600. This index is 700. It's not 10s, it's 20s. 600, 620, 40, 660, 680, 700. There's a way that it's easy to kind of figure out. Sometimes there's 4 lines in between index contours. Sometimes there's 5 lines. What you can do is figure out what the index contours count by. So the index contours count by 100, and there's 1, 2, 3, 4, 5 contour lines to get to the next one. So 100 divided by 5 would be 20. So that's one way I like to figure it out, or just sit here and do the counting until you match it up correctly. So we know that this one's 700, and we know it counts by 20s, so this would be 720. The next contour line, if there was one, would be 740, and so this peak is less than 740. In fact, it's 726. Hope that makes sense. Yeah, so we've already looked at this line again. Reminder that the closer the lines are, the steeper the path. Okay, so right here, let's look at the closest lines. Yeah, that we'd be over here, so this would be the steep side. If you're going to walk up this hill, yes, this is the fastest route, but you're talking about the fastest route to go from 80 all the way up to 214. You're climbing elevation pretty quickly. That must be a steep elevation, versus over here, nice gradual walk this way. So here we go. Again, you can kind of see the side view of what that looks like. You can see the side view, 2 little hills. This hill higher than this hill. It has more circles. Okay, and I love this question. It says, what's the difference in the points of elevation? So we're looking at Z and Y and X. So the first thing you need to do is, what does X equal? What does Y equal? And what is X, Y, and Z? What do they equal? So let's do X first. We know that this is 200, this is 300, and it's 1, 2, 3, 4, 5 in between, so we know our interval's 20. Sometimes they'll give you the intervals, sometimes you figure it out. I like to figure it out on my own. So if this is 320, as you walk along this line, the entire time you're walking along this line, you are not getting any higher or lower in elevation. So let's look at this 400 line. Same thing. You could walk around it the entire time and never get any higher than 400 meters above sea level. Same thing with this line over here. Just walk on it. You'll never get any higher or lower. Anyway, so what is X? This is 200, 220, 240. X equals 260. Y equals 220. Z equals 120, 40. Z equals 140. And then you have to find the differences. So the difference between Z and Y, you subtract those two, giving you your difference. Z and X, subtract those two, giving you your difference. X and Y, subtract those two to give you your distance. That is the big deal with topographic maps. If you know those things, you know how to identify what a side and a top view, which ones will match, and you know how to find the differences, and you realize what's steep and what is not steep, that is it. That's all you need to know for topo maps. So I challenge you to pause this video and go ahead and try to answer these questions. because the more practice you get at this, the better you get at it, the easier this information gets, and you can take those test questions and cash them in when you take your STAR test. So that's the end of topographic maps, friends. We will talk soon.